Hello, and welcome to another edition of Mr. Chappell's Chemistry Screencasts. Today we're going to learn about naming ionic compounds. What you'll learn in this screencast is how to turn a formula into a name. You'll also learn about how to turn a name into a formula. Now there are a couple of things you're going to need. You're going to need a periodic table with the preferred ionic charges labeled on it. You're going to need your nomenclature flow scheme. And lastly, you're going to need the listing of some common ions. This is the listing that I passed out in class. Now, to take a formula and turn it into a name, you can do that in 3 steps. The first step is to always list the cation first, followed by the anion. The cation name is always the same as its elemental name. And lastly, if the anion contains only one type of element, then you add the suffix "-ide" to the root name of the element. If the anion contains more than one type of element, then that means that the anion can be found on your common ion list. Now, to take a name and turn it into a formula, you always put the cation first, followed by the anion. You want to make certain that the net charge of the compound must be equal to 0. And to do that, what you do is you trade the charges on each of the ions and make them subscripts on the opposite ion. And you have to remember to always write them in the lowest possible whole number ratio. Let's go ahead and get started. Okay, now we're being asked to give the name for each of these ionic compounds. And they are all ionic compounds. They're made up of a metal and then some combination of nonmetals. And the first one is, the first element listed for the first example is Mr. Sodium. So you write down sodium. And you will notice that the second element contains only one type. So we will add the suffix "-ide" to the root name of the element name, and that becomes bromide. Now, if you're thinking to yourself, that seems pretty easy, and the answer to that is it's pretty easy. It's not that difficult. Okay, for the second one, the first element listed is potassium. So we write down potassium. And the second element is nitrogen, and it contains only one type of element, so we're going to write down nitride. And you may be wondering, hey, what about the subscript 3? Well, you don't worry about those in ionic compounds. We'll find out later when we take names and turn them into formulas why that is. Okay, well, here we've got a special one. We've got a metal and a nonmetal, but the metal is a transitional element. So what we need to do is we need to figure out what the charge on the iron is. Iron has some charge. We'll just call that X. However, we do know what the charge on the chloride is. Chlorine is always a -1. And we've got 3 of them. So that means when we take the iron and add it with the 3 -1s, the rule says that the sum of the charges has to be equal to 0. Well, darn it, without too much work, you can probably figure out that the charge on the iron would have to be a +3. That is, X is equal to 3. So when we name this compound, we need to name it according to the stock system. So it's going to be iron. And then to tell the person that the charge is a +3, we put down parentheses, and then Roman numeral 3, close parentheses, and now the name of the anion. Well, there's only one type. There's 3 of them there, but there's only one type. So this guy is going to be called chloride. Okay, for the next example, well, darn it, the first one listed is nickel, and that's a transitional element. So once again, we don't know what the charge on the nickel is supposed to be. Well, I do, because I wrote the problem, but you probably don't. We do know, however, that that second element there, iodine, is a -1. And since the sum of the charges has to be equal to 0, that means when we take the nickel, whatever it is, and we add to it 2 -1s, because there's 2 iodines there, the sum will have to be equal to 0. And so without too much difficulty, you probably figure out that the charge on that needs to be a +2. So when we name the compound, it's going to be nickel. And then we put parentheses down and then a Roman numeral 2, because it has a +2 charge. And the second element, the nonmetal, is only one type, so we're going to call that iodide. Okay, for the next example, the first element there is pretty easy. That's Mr. Sodium, so we write down sodium. And now for the second element, well, wait a minute, you've got 2 nonmetals. You have more than one type. So what you need to do is you need to find on the common ion list PO4. And if you do that, you will find that its name is phosphate. And that's how you do it. Okay, well, here are some other problems. This is an example of taking the name and putting down the chemical formula. Okay, so for the first example, we've got potassium and bromine. And for the potassium, that's a piece of cake. So potassium is in the +1 column. So we write +1. And for the bromide, it's going to be just bromine and nothing but the bromine, because it's got that suffix IDE, and that is a -1. So what we do is we take the superscripts and we trade them and make them subscripts. So the formula would be Mr. Potassium and then bromine. We don't write the number 1 when we're writing down formulas. But if we were to, that's what it would look like. There would be a 1 on each of these, but that's a big no-no. You don't write 1s. Okay, for the next one, it's calcium and chloride. And for calcium, it is in the +2 column. And for the chloride, it is in the -1 column. Okay, so now what we do is we take the superscript and make it a subscript on the other. And this, let me choose the right color here. We get calcium, and now chloride. It's only got one type of element because it's got that suffix IDE, and we put a 2 down there. And that 2 is the same as this 2, which was on the calcium. And if we were going to put 1s, then the 1 there would be on the calcium, but we don't write down 1s when we're writing down chemical formulas. Okay, for the next one, oh, whoa, we've got the stock system there. So that's Mr. Nickel. And nickel has a +3 charge. How do you know? Well, that's what that Roman numeral 3 is telling you. And the oxide is -2. So just the oxygen, because it's only got the IDE suffix. So what we do is we go ahead and switch the superscript, and that means the nickel's going to get a subscript of 2, and the oxygen is going to get a subscript of 3. Piece of cake. Okay, for the next one we've got magnesium, and magnesium is in the +2 column. And we've got carbide, and carbide is in the ±4 column. Well, it's being named last, so it has to be an anion, so this would be an example of -4. And so what we do is we write down the formula, go ahead and trade the subscripts, and this becomes Mg. Oh, wait a minute. A 2 and a 4, well, that's divisible by 2. So what we need to do is we need to reduce it to the simplest whole number ratio, and the formula we get is that. So the 4 got moved to the magnesium, and the 2 got moved to the carbon, but that's not the simplest whole number ratio. That's 2 to 4, which is the same as 1 to 2. And then finally, for the last one, we've got barium nitrate. And barium, of course, being in the +2 column, is a +2. And nitrate, well, you can see it's got that suffix ate, so that means we need to look at our polyatomic list, and we would find that a nitrate, it looks exactly like that. So we're going to go ahead and trade the subscripts, the superscripts, make them subscripts. So for the barium, let me choose the right color here. The barium is going to get a subscript of 1, but we don't write 1s. And now the nitrate needs a subscript of 2. Well, the whole thing, the NO3, that whole thing is a nitrate with a -1 charge. So in this case, what we need to do is use parentheses and tell the person that we need 2 of the whole thing. So use parentheses when you have polyatomic ions and you need more than one of them in your formula. And that's how you do it. And that concludes this lesson. It's joke time once again. Hey, did you hear about the 2 silkworms that were in a race? Yeah, they ended up in a tie.